Square roots. Learning goal. I can explain what a square root is and describe some properties of square roots. Let's take a look at arranging number tiles in Polypad to try to form a square shape from different numbers of tiles. I'm going to start by dragging out a bunch of squares here until we've got 36 squares. So I've got 36 squares dragged out in 3 groups of 10 and then a group of 6. The next step I want to do is try to form these squares into forming one big square. So I can do that by, I first need to break all these apart, so I'll go ahead and split them apart and then start moving some of them around. So I'll take this chunk here and move them down here. Take these 4 and move them to there, and then take the last 2 and move them down there. Once I've done that, I can see that I've now got a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6 grid. And because it's filled in, it's a full square, there's none of the squares missing. For instance, it didn't end up like this. Because I've got everything filled in, I know that I've got a square, a full square, and when I measure them out, it turns out that the square is 6 by 6. Let's try a different question this time. Suppose we started off with 2 blocks of hundreds, and then I'll add in a couple more blocks of tens, and a third block of 10 that I'm going to then cut in half. So I've got 225 squares. I want to follow that same process to see if I can form these into a square. So I'll go ahead and split them apart, and then start rearranging. So I've been able to form a square, and if I count them up now, 15 across, and similarly, I'll have 15 down. So I end up with 15 by 15. With each side of the square being equal to 15, I know then that 15 is the square root of 225. Now let's see what happens if we try a number that doesn't work out quite so well. Supposing we started with a number like 200. I'd follow through the same process. Go ahead and split these apart and then split those apart. So I've got individual squares. And I'm going to go ahead and take a chunk of them and start rearranging them. So I end up in this case with a square that's 14 by 15. So what then if I tried to get it a little more consistent? I could take some of these off, and I'll fill them in down here, see what happens when I move those around. I still don't quite have a perfect square. So because I don't have a perfect square, I know that my square root is going to lie somewhere between the numbers of 14 and 15. Without getting into too much detail, you can see that what you'd really need to be doing would be to take off those from the side. By doing that, we'd now have a 14 by 14 square. We'd have to then split these last 4 remaining ones into really, really thin pieces and put them along this side and along this side. So they'd both be a little bit more than 14, but not nearly as close as 15. So we know that the square root of 200 is going to be a little bit bigger than 14. So I might estimate that it's maybe going to be 14.1 as an example. You could do the exact calculation on your calculator, but you can see how working with the tiles gives you a sense of what the square root should be, regardless of the shape, the original shape that you start off with. If you move it towards being a square, it'll help you to understand what the square root would actually be. So from that activity, we can see that if we can take all of the tiles and form them into a perfect square, the length of the side of the square will be the square root. However, if we can't form an exact square and there are still chunks left out, and the 2 sides are even, that will give us some indication that the square root of the number of tiles will be a little bit less than the size of the edge. Or if we have managed to form a square that has a few tiles left over, then we know that the square root is a little bigger than each side of the edge. The square root of a number, x, is a number that you multiply by itself to get the original number x. The square root of 25 is 5, because you multiply 5 by itself, so 5 times 5, and you get 25. The square root of 81 is 9. You multiply 9 by itself, or square it, 9 times 9, and you get 81. Of course, the square root of 9 is 3, but the square root of 10 is 3.16227766, and so on. Squaring a number by putting it to the exponent 2 or multiplying it by itself is the opposite operation of calculating square root. In the same way that multiplication and division are opposite operations, square and square root are opposite. Perfect squares are numbers whose square root is an integer, or a whole number that can be either positive or negative. 4, 9, 16, 25, 36, 49 are all perfect squares. Finding the square root of a number that is not a perfect square will usually require you to use a calculator. Lesson summary. The square root of a number is the number that you can multiply by itself to get the number you started with. For example, the square root of 625 is 25, since 25 times 25 equals 625. The square root of 10,000 is 100, since 100 times 100 equals 10,000. The square root of 30 must be between 5 and 6, since 30 is between 5 times 5 and 6 times 6. We use the radical symbol, seen here, to show square roots. For example, the radical symbol followed by 40 means the square root of 40. So, radical symbol 625 means the square root of 625, which is equal to 25. Conversely, 25 to the exponent 2, or 25 squared, is equal to 625. It's useful to know the squares of numbers from 1 to 15, and perhaps the square of 25 to help you estimate other square roots. These perfect squares and their square roots are as follows. I won't review them all here, but it's a good idea to go through and memorize these if you don't know them already. Most of them you should already recognize if you've learned your times tables up to 12 times 12. That just leaves 13, 14, 15, and 25 to learn. It's also useful to realize that since 30 times 30 is equal to 10 times 10 times 3 times 3, the square root of 900 is 10 times 3, or 30. Other perfect squares of multiples of 10 also relate to the perfect squares above. For example, 1600 is equal to 100 times 16. So the square root of 1600 is 10 times 4, which is 40. To explain this a little more, 1600 is equal to 16 times 100. Since we're looking for the square root of 1600, that's the same as the square root of 16 times the square root of 100. So that's how we get 4 times 10, being 40. To model a square root, you can think of the number as the area of a square and try to figure out the side length. The side length is the square root. That's basically what we were doing when we showed the Polypad video. For example, the square root of 36 is 6, since a square with an area of 36 square units has a side length of 6 units. 36 is called a perfect square because the side length is a whole number. In other words, 36 is a whole number raised to the second power. In this case, that whole number is 6 that's raised to the power 2. It's more difficult to physically represent the square root of a number that is not a perfect square. We can only estimate. And that's what you saw when we were working in Polypad and tried to do the square root of 200, which doesn't have a whole number square root. For example, to model the square root of 72, you can make an 8 by 8 square that has an area of 64 square units. You have 8 square units left over that have to be split up evenly around the right and bottom edges of the square. If you cut each of the extra 8 squares in half, you could add half a square to the right of each of the 8 rows and to the bottom of each of the 8 columns. That way you almost have a square. We're just missing a little tiny piece here. That shows us that since root 72 is the side length of that square, then root 72 must be about 8.5 or 8.5. It's going to be just a tiny little bit less than that because we've got the corner missing. It's always best to estimate first, but you can use a calculator to calculate a square root. For example, you could estimate that the square root of 385 is a bit less than 20, since 20 times 20 is 400, and you're just trying to get to 385. You know that 20 times 20 is a little bit big, so the square root of 385 should be just a little bit less than 20. You can use a calculator by pressing the digits for 385 and then the square root button, which often looks like one of these two. Also note that some calculators require you to hit the square root button first and then type in the number 385 that you want the square root of. Square root of 385 turns out to be 19.6214687. You might estimate this as 19.6 or 19.62. To check the answer, you can type in the number and then square it or just multiply it by itself. You should end up back at 385. Key terms. Perfect square, or square number, is a number that results from multiplying a positive integer by itself. The perfect squares are 1, 4, 9, 16, 25, 36, and 49. For example, 9 is a perfect square since 9 is equal to 3 times 3. And you can see if we lay it out in a grid of dots, we end up with something that is in fact square. Square root, where we use the radical symbol, is a number that's multiplied by itself to get another number. For example, the square root of 25 is equal to 5, since 5 times 5 is 25. Your turn.